in the space weather
Yeah.
chat if you like
Okay.
cute cats at least.
Why is this not working? Ay,
We
ay,
got a
ay, ay,
substorm.
Okay.
Yay! I
Okay, I
don't like
think
that
it.
Heartland was right, but I like that it's ready at least.
Okay, we're good now. It's working. Okay. It was probably that whole little thing that I just did, and
Just to try.
oh my god, like it's probably all in there, and I just didn't realize it. Okay.
All right. Well,
All right.
yeah,
All
we
right.
wait.
Margaret's here
Oh,
and she's
yep.
in, so okay. All right. I think we're officially a go. I think next time I'm not going to schedule it. I'm just going to hit the button that says stream and stream it.
Okay.
All
Hi,
right.
Margaret.
So, okay. Anyway, welcome in, everybody. Maybe joining us. Um, Sorry for the technical difficulties. Once again, I'm trying to use OBS, and I'm new to it. So I tried to schedule something that didn't work. You know, it's just whatever.
The normal tech thing.
I'll eventually figure this out. I don't know. And then I'm supposed to get like a green screen set up. So yeah, whatever. We'll see.
One step at a time.
One step at a time.
Yeah.
So yeah, today we're going to talk about current events and Coronal Holes. In that order, I think. I think that's what we decided to
They're
do.
kind of similar in this case, because
Yeah, because it is Coronal Hole related, so it checks. What did the kids say these days? It tracks.
Mhm.
I don't know.
Yeah.
I'm the youngest one here, and I don't know that answer.
Yes, you are. Okay, so anyway, I will hand it over to whoever has the current solar wind data up. I forget if it was Christian or Tanya.
Dibs.
Dibs.
Well, not dibs necessarily, but I have it up, so might as well.
Get to it.
All right.
Get to it.
So we're, yes, definitely seeing coronal hole influences now. It's a positive polarity hole. So I'm going to say, ideally, when the magnetic field started becoming pretty consistent over here, we had some density increase a little bit, but I'm thinking based on where the coronal hole was at in the SDO, it's not going to be like a standard hardcore signature. We're not going to see the standard density rise up and then, everything else come from that. We did see an IMF jump, and I do believe that's what we're seeing now as well. Speed is now starting to jump as of the last 6 hours. Starting to see 10, 11 nanotesla BT. BX is also becoming fairly negative, showing a positive polarity. And BZ is now hanging out in the negative area, which is triggering a substorm that is just now going on, so we're likely getting some pretty good aurora in the Scandinavian regions. Probably not very much, I'm assuming, on the eastern coast here. We're still pretty far into the pre-midnight sector. 8:30, maybe Maine? Maybe? Just depends on cloud coverage. But point being is we're likely going to see some speed variation anywhere between 400 to 500. I really don't think we'll see consistent speeds, and it'll probably lag off and die in the next couple of days from at least the shape of the coronal hole as of now. That is based on GOES imagery, because SDO is still not here. I said I wouldn't complain about that, but that's my complaint for today. So expect like high latitude and maybe some brief mid-latitude substorms. Probably will be confined to high latitude, though, once the full coronal hole high-speed stream is here. BT generally drops pretty significantly, even with the higher speeds. We usually get some pretty good aurora, but usually high latitude stuff. So it just depends, though. That's all I had for really current events, because that's really all that's going on. If we want to also mention, which I don't have, you have a video of the X Flare? Because I did not.
I don't think I.
Let me share the screen on that one.
Perfect. Go ahead.
I think I have it.
We'll talk about the X Flare that basically
Yay.
was something to talk about today.
Yes.
Even though it really wasn't.
The sun's been so quiet lately that it actually gave us something to talk about, so that was kind of nice.
Shocking.
And this is it's the Suvi GOES stuff, because again, that's what we have.
Yes, it is. You can tell by the quality.
Yes.
Again, wider field of view. It's nice, especially for the really pretty filament eruptions or the limb eruptions for 304. You're going to be able to see a lot more as it comes out, but try zooming in on it. You'll get sad. Anyway, I guess I'll keep going into this. So yeah, X28 as of X2 as of earlier this morning Not very exciting. Differential imagery shown a small coronal wave that went through. Did not really traverse much of the solar disk, if any. I don't think it even made it to like halfway through the western hemisphere. It was pretty weak. So, as seeing Glasgow, we saw a small puff outward, very narrow as well.
Yeah, I think I put that video
Oh,
in
here's the
there.
video. Yeah.
Yeah.
I've made it in HelioViewer. Oh my gosh.
I feel like a very proud teacher, I guess, at this point, even though I just showed you the basics. Yeah, but anyway, we're talking narrow. That's got to be 80 degrees at most, I would say, for a full width per angle. Very Western. And then we have some models that have already modeled it. So I will go ahead and let Tanya take that part since she said she wanted to.
Sure. So NASA, as usual, was first because they do have assets to protect. They modeled it as a very, very, very glancing blow. Worst case scenario for Earth is KP4, and we know how well that turns out most of the time. So yeah, do not expect much. And that's assuming whatever magnetic field that's coming with that CME is all going into BZ. That will give us KP4, but arrival sometime around the 11th, but there is a difference in sort of disagreement between modeling agencies. NOAA modeled it as a complete miss, which is not that far off, considering how narrow it was and where it was, how close it was to the west limb. And we have two Hux models. Why do we have two? Because Met Office actually clocked that CME at a lot higher speed compared to M2M. So everybody is running with a speed of about 677 kilometers per second, and Met Office is putting it at 850. Their initial estimate was actually 1,000, and that gave them an estimate of arrival sometime around the 10th. Right now, I think it stands closer to December 11th. And we see a difference in timing of, not much of a difference in timing of arrival, but their probability arrival is different because slower CMEs have a time to expand. So if you start at narrow and just going fast and narrow, you're going to stay more narrow. If you're starting narrow and going slow, there is a chance that it's going to expand and include Earth. How it's going to play out, we're going to see at L1. So,
Yep. What's the
not
motto
expecting
for
much.
our thing?
Not expecting much from this one. L1 or bust. Yep.
Ah.
All right, and we're moving into Coronal Holes.
Which I can take a few of them, and then I know Mary Beth, you definitely have your case study, and if you want to cover like some of the previous starts, but
Sure.
I can at least start us off. So we're in the season. So the latter half of the solar cycle, we're going to start seeing some bigger and bigger coronal holes stretch further and further. Hopefully more and more. Like for this example, this was a 2023, so this was last year's, and we haven't seen many since this. But this is a very nice transit equatorial coronal hole. Those are generally the more effective ones, A, because it covers more just area in general, and it really puts the Earth right dead in the center of the mix. And B, it usually means there's some sort of high speed involved in it, and usually a high differential. If we're coming from solar wind, that can mean a pretty big shock in a CIR form, or SIR, depending on the coronal hole. Right now, we're only seeing these minor ones, but notice more and more as the rotations increase that we're starting to see more and more at mid-latitudes, and every now and then we'll see a few hit the middle latitude or lower latitudes and almost across the disk. Those are the ones we're going to want to wait for. In about 6 to 12 months, we're going to start seeing the big ones. And these big ones can be big. But the point is, these coronal holes are open magnetic field lines in the sun. They are not closed. Active regions have the plasma traveling out of the sun and back into it, basically. These, at least the way the coronal holes are shaped in the magnetic fields, go out into space. They do not converge. They do not return. They go out from the sun, and they're not coming back. That is what speeds them up. So the magnetic field acts as basically a high-speed lane in a super busy highway. So it's those, POV lanes? I don't forget what they're called. But the idea is, yes, thank you. I never remember that because I never get to use them. The point is, it's a pretty fast way to get through, and that is exactly what these are. I like this because it's a better example of the actual magnetic fields. We're looking at the yellow lines here on the sides. These are all active region magnetic fields. They return from the surface and go back into it. And then we have the red ones, which are open. These are the ones that go out. Generally, the coronal holes are in the poles, and then sometimes, depending on the time of the cycle, we have some decent ones in the center. Those are all going out and accelerated, and those are going to be the high-speed areas. So it acts as a high-speed hose, basically swirling around, constantly hitting the Earth every 25 to 27 days, especially during the solar minimum times. But this is the general shape that they take as far as what they do and how they are different from active regions. They look dark. They're not actually missing, and they're not actually holes. This was a really fun debate back in 2012, I want to say, with Fox News. It's not a hole. It's not literally a hole. It's just very, very low density. Therefore, it appears very much not bright in comparison to the active corona. These are some nice examples, but I'm going to go ahead and I think, Mary Beth, you can go ahead and take it from here.
Oh, okay.
Because I think your case study's coming right up after this, I think, right?
Yeah, I think so. I sort of remember the order of this.
I'm going based on memory. Yeah, so I don't.
But I mean, it's kind of a cool little slide because it shows,
Oh, the bandograms.
Yeah, how they evolve over time, throughout the cycle. They, the more mid latitude ones, and then the big polar ones when you're at solar, well, when you're at solar minimum, basically, because you have your big one in the north and the south, so it's open. Then it flips and whatever. So yeah, this is our bandogram. It shows the cycle's pretty good here, and you can kind of see that we have hit the reversal, which is cool. So we're gonna start getting those polar coronal holes again, probably the next year and a half.
Yeah, we'll start seeing the formation over the next 6 months, easy 6 to 12 months roughly.
Yeah. So yay. And then, so this little chart, which is fun, it kind of shows how Aurora Chasers were always after these CMEs all the time. But if you look at this, and you look at the HSS-CIR related number of, storms, it's a lot more than the CME related one, isn't it?
Nope, at least for a weak and moderate, it looks like there's an equal probability between the moderate storms during the cycles.
So these are actually good things to chase, and they're relatively predictable, which is something we have a hard time even saying when we come to space weather. It's like, because nothing's really predictable, but coronal holes, they tend to live, and they will go around and around and around. So if you get one hole that provided some decent stuff, you can somewhat count on the next month coming back around. So yeah, this is actually something cool to chase, just for that reason alone. I mean, you're not going to get the big stuff out of it, like the G4, G5 things, but if you're in a decent mid-latitude location like Minnesota, which my case study is going to be on, you can see some really fantastic stuff that comes out of this.
This is a perfect chart for all of that too. Sorry, one more comment on you. If you don't mind going back one more. Just re-emphasizing the fact that, you've got your weak storms here, which your weak storms are going to be the pretty good high latitude ones, but the high speed streams way outnumber any CME related ones. But for the extreme storms, like we have the October storm or anything in May, or even the Halloween storms, CMEs pretty much drive that purely. But there are still coronal hole events that can do that.
Mm-hmm.
I like this chart. That's a cool one.
Now we can go to the next chart. Oh yeah, this is the latitude one, geoeffective latitude. I mean, it kind of makes sense that, the more equatorial that these holes are, the more geoeffective they'll be. The speed will be faster when it hits here. So this is kind of a little bit of a, I don't want to say no-brainer, but kind of like common sense. If it's out of the realm of where the Earth strike zone is, we're not going to really see as much. You get closer to the equatorial region, they become more geoeffective. So that's just kind of a little case study showing that. And then I think the next one is similar, but it shows the speed. So this is the same type of deal. And so it shows as you get out of the the different degrees in latitude. So the further away you get from the center, or I should say ecliptic, I guess. Not ecliptic, right? Yeah.
Let's say equator here.
Yeah, equator. I want
enough,
equator. But... Yeah. You start to lose the speed, and then so you want the speed because that'll drive this into the more dramatic events. So the more central it is, the better. On the edge, maybe not. Like the one we're getting hit today, I think it was more edge related, if I remember correctly. Yeah. There was one. Actually, the one was kind of. I think it's in here. There's one that's kind of center and one that's not. So We'll get to
And
that
they're so
slide.
tiny.
Yeah, they're little. They're not like the monster that we're gonna talk about here. Oh, and then this chart right here shows this. We talk about the Russell-McPherson effect. The one on the left-hand side shows that pretty good because you have your spring negative, autumn positive.
Snap.
Polarity,
Or for
snap.
those in the southern hemisphere, what was the other one?
It was
Span.
Span.
yeah,
Yeah, span.
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 Yeah, and you can see month 3, 2, 3, 4, versus on the other end 9, 10, or 8, 9, 10. So autumn, fall, or autumn, fall. That's the same thing. Spring, fall. So that was I liked having this one in here because it helps drive home that fact about the when we talked about Russell-McPherson and the seasonality of these things. So yeah, and then what was it? The next one is distribution.
So the
CRs,
size, the size of Coronal Hole, even the small ones, fairly small ones, can still drive decent storming. So that's basically the percent of the solar disk. And big ones are fairly rare, but they definitely cause a lot of storming. And the smaller ones still are capable of doing that. So do not dismiss it for the size alone.
Size doesn't matter.
More so where it's more so I'd say latitude matters more than size in this case. It's not the size that matters, it's
how you use
place
it
on the globe. I can't make that similar. Yeah, we'll go with
that. I'm just sorry. Okay, my bad. Anyway, back on track here. So this kind of shows the when you're talking CMEs versus SIR, CIRs, high speed streams. And they're structurally a bit different. Because basically your stream interaction region is when the fast stream catches up to the slow stream and it compresses. And that's how you get your bump in activity. Whereas the CME is like a big expansion and a flux rope. I'm losing my words here.
Yeah, I mean that's pretty much it.
It's like a flux rope configuration. It's not configuration. It's not what I'm looking for, but it's just different. And CMEs have a much more punch to them when we get hit by a good one, but we can't dismiss these interaction regions because they can drive some really good activity, especially.
I've seen actual shocks, so I mean almost indistinguishable from a CME shock from a very good SIR shock coming in. Especially going from a slow solar wind to very fast and let's say a potent coronal hole, it can almost look like an actual CME, but then you'll register the fact that it doesn't look like a CME in data. You'll see the density then drop and
the
speed still
rise.
Climb over time. Yeah, IMF drop as well. There'll be no consistency and you'll have pretty much no BZ component at that point once you get the HSS.
Rock on. So here's Here's my little case study. So I put this together in HelioViewer, but if you look at this is 211, and Tanya will have to play it a couple times here because I don't know how to make it loop yet. But that's a monster coronal hole. Like it's all the way up transequatorial. It's neat to see because it's got a couple active regions in there because this was on the ascending phase of 25. So you're starting to get these active regions showing up. But you have these monster coronal holes. And this was responsible for a high NG2 event in Minnesota. And it was at the speed, let me see, I have this chart in here, but this one, because I could read it better, I threw it in here. But it reached almost 700, 650, which was fast. That's fast. So it was pretty good to drive some decent activity, and then even with the density spiked up. Look at that, like up to 60.
That's a nice CIR.
Yeah, it was really.
I mean, that's almost shock worthy.
Yeah, it was a good. And actually, what triggered the main picture that I'm going to show here was this drastic shift from positive BZ to negative BZ, like instantaneously.
Quick comment before we go to the next one too.
Yes.
Just on the trending of it, so showing the BT and noticing that it's not an actual shock. We're not seeing a huge increase all of a sudden. It's a fairly gradual increase over about 2 hours to a peak, which then steadily drops as you get further into the speed. So the speed and the BT at this point, and or density even, should be inversely proportional to each other, roughly, just to be approximate. So that's how you can distinguish them. You're seeing BT increase with the density, and then speed is going to up itself more as things decrease from there. BZ is pretty erratic, but can be constant, like in this one. So that's my comment.
Oh, and yeah, it illustrates it very well. So yeah, this is what I saw. And it was a memorable night because this was the first time that I've ever seen overhead aurora, and it was caused by a coronal hole. So that's my, that's our whole takeaway of this entire discussion tonight, is that we can't discount coronal holes because they can drive this kind of activity. It's just pretty phenomenal. I think it's really cool that we could go back in Glendale and pull that substorm.
Yeah, I
chart
didn't realize
too,
Glendale
'cause
had that info.
I didn't think it had that archive yet, and it does. But
That's pretty deep.
that corona is basically what that big substorm that you see there, that minus 1400 NT nanotesla. Yeah, it was like it came on so fast, and I just remember sitting there. It was like, oh, that's getting higher and higher and higher, and I was like, oh boy. I was like, is this really happening? Oh, it was really awesome. This was after like the whole night of like nothing, 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 and then it just like took off.
Boom.
And it continued to storm pretty much the whole night, but the main show was that first substorm there. That was by far the biggest one of it. So I always remember that because that was the first time I've seen the corona. Yeah, coronal holes. So there's we'll not discount them.
And that's not even the fastest. So I think
Yeah.
back in cycle 24, the descending phase for sure, I saw there's a few that hit 800 kilometers a second for a while.
Yeah.
I mean, I've seen much faster coronal holes than most CMEs that I've seen.
I think Tamitha was saying that because this cycle is a little bit, outperforming than we thought, that we might see a return of the
Oh, that's right. She's expecting the huge increases,
the
right?
fast coronal holes too. So cross fingers.
Yeah, exactly.
Yeah.
Get some of those high speeds going.
So yeah,
Right.
I think we have more after this.
Yeah, we do.
Yeah.
This is more sort of current state of events, and this is what coronal holes look like in solar orbiter. They do come pretty much like we see the gradual rise in BT, which is right here, and then you see a decline over time and very erratic BZ. There's a little bit of a flux rope here for no good reason at all, but this is what we see. So this is a synoptic map, and I like them a lot when we do not have SDO.
Right, I was gonna say in lieu of SDO, these synoptic maps
Instead of
are great.
SDO, I decided to let somebody do the work and
just got
actually
over
map out the
crying.
coronal hole. I'm sorry. We'll have a cry session afterwards. But this coronal hole probably moved in and caused some storming, not storming, but some disturbance yesterday. Nothing major really. But there was a little bit of a rise in BT that sort of kind of didn't look like shock, but it was very gradual. And it just stayed there consistently. BZ dropped but didn't go very far. And we know when it happens, we're going to expect some steady magnetospheric convection. And that's exactly what happened. It was kind of gradual ramp up in terms of activity, but there was some activity overnight. So the polar orbiters actually caught some nice aurora. Nothing spectacular, but nonetheless, it was active night. And you really had to look at ground magnetometers or Glendale app to see what was happening, because unfortunately, this minor stuff that actually gives you aurora, and I did saw one of the Aurora Chasers from Canada saying that she essentially had an all-night aurora in Canada, which is what I would expect based on this data. It would be fairly active at higher latitudes. For mid-latitudes, maybe green glow in the horizon, with maybe occasional flare-ups for sort of substormy conditions. But that's about it. So, unfortunately, GOES magnetometers did not see much.
Nope.
So this is very typical for SMC, where you will have it very active, but there is really no reason for magnetosphere to reconfigure and go into major substorming. So we're going to end up seeing very minor stuff for high latitudes, but nonetheless, it's going to be there. And if you're trying to catch it with the GOES magnetometer, you're going to be disappointed because it's going to be very, very difficult to see there. Same goes for auroral electrojet. There are definitely a few spots where you probably saw some flare-ups in Aurora, but they're kind of hard to see in the background of steady magnetospheric convection. So ground mags, Glendale Lab, those are your best sources for now. If you don't want to sit all night with ground magnetometers with your favorite
We've
line,
never
be it the
done that.
Churchill line or Alberta line. No. But yeah, go to Glendale Lab. It's gonna do the work for you.
That it does.
All right. But one important thing about coronal holes, they can cause steady convection because they do carry their own magnetic field, even though it may not be the major one. So yes, majority of the impact and storming we're going to see when that interaction region passes through. But what happens afterwards, it still can cause fairly decent aurora, and it may be 2 continuous days of aurora for passage of major coronal holes. So if things align, we're going to see enhancement of the auroral oval for the coronal holes that last several days at a time continuously, with substorms here and there. So I'm looking forward to it.
Yeah, and I'm sure some of the people out there probably recall, like, 2019, 2020.
Oh, I go to Alberta during that time. Like at least the Albertans were constantly getting 1 month at a time, every month on the queue.
And it was always like a couple
2 days of
worth.
just great aurora, and then nothing, and then it come back, and it was, I think, 4 rotations that major coronal hole was around. It was months.
So I'm personally looking forward to it.
Plus, if we get a big CME combo with one, which is still very possible.
Mm-hmm. There's been a few case studies out there where, like, there was a coronal hole that seemed like it was stronger than it should have been, and then when you do the reverse forensics on it, found out that there was a stealth CME that was embedded in it, especially along the edges of them. Like, sometimes that'll let one off.
Just combined with the CIRs on there too.
Yeah, and it gives it that extra punch. So if you get those the ones that tend to be a little bit stronger with magnetic field, it probably might be helped by a stealth CME.
Yeah, coronal holes do some interesting things with CMEs. They can interact, and you can get greater geomagnetic activity than you would expect out of coronal hole alone. But sometimes they actually deflect CMEs. CMEs do not like to travel across open field lines, so there's CME that's launched very close to coronal hole. It might be deflected. And depending on the way it's getting deflected, it either will be geo-effective or it's going to be actually less geo-effective than you would expect. So with coronal holes that are now moving into central position, they're kind of taking center stage. They can push some of the central CMEs, and they're going to look more like glancing blows. So you would expect this huge CME to come and deliver G4, and it arrives and
you really want the CME after the fact.
Yeah.
More helpful getting them on the tail end and having the magnetosphere recover, and then boom, CME hits. Love those.
But yeah, they can combine. So most geo-effective in terms of storming would be combo CME. CME coronal hole is second best. So, and we can look forward to that in the declining phase.
Yeah, because now it's a battleground now, as it goes towards
which one wins.
Yeah, as it goes towards cycle 26. So, yippee skippy.
Before we get at least a few years before that, I'd say another, 3 or 4 years of activity at least before we start seeing long, dramatic, empty periods of nothing.
Yeah, that was the other thing. Cycle 24, in terms of being like the weird cycle, is that it had a long minimum, like, declining phase. It just kind of like never ended, or seemed like it was.
the at least increase to max is like 1/4 or 1/3 of the actual cycle. So generally the
Yeah.
descending phase is slower, but yeah, cycle 24 not only had the slow descending, but then the slow uprise into finally getting to 25.
Yeah, it was just a...
Yeah.
Hated that cycle.
Yeah, it was a very blah cycle. But we got some action now, so it's all good. Well, anyway, that's all we had for the day. So, hope you all enjoyed it. If you have any questions, let us know. We'll get them answered, or at least as best as our ability. But as always, thanks for tuning in, and we'll figure out something to
Thanks,
talk about
everyone.
next week.
We'll do the
The sky
sunspots
is
next
clear,
week if
yeah.
we can.
How was that? Sunspots?
Sunspot, yeah, I still need to do the sunspot preach.
All right, we'll do sunspots next week then, unless anybody objects.
Oh, the sun would be the only one that objects, I think.
Yeah, we could always get an event that we have to talk about instead. We
That
still
doesn't
have to
take
go
5
over
seconds.
the ground mags too.
That'll be a series, I think.
Yep.
Yeah. So
I
We're
think
still waiting on
sunspots will
confirmation.
be a good topic potentially next week, because what we're going to see is, what we have seen at least this cycle is we see either coronal holes or we
the
see active
region
regions.
longitudes. Yep.
Because that's actually a separate topic. The hot longitudes,
Oh,
and
yeah,
that's true
yeah.
for both
How
active
convenient
regions
is it we do this
and
once a
coronal
week?
holes. Yeah.
And that's how much it cycles. Once a week, we get something different in that area. Generally.
It's all good. All right. Well, I will let you guys be. So, thanks for tuning in, and we will see you next week.
Bye, everybody.
Bye.
Adios.